Okay, once again, it's another fun time to have fun using cloud. Let's play. Welcome to Cloud Training for Enthusiasts. Yeah, your dream to cloud fairyland comes true. I'm your pilot again, Osatu Ahmed Patrick Aigogu. And last week we talked about accessing our private clusters, private VMs using a key agent, and we configured an application, a web application called Nginx on a private VM, and we used a load balancer, application load balancer to access it. Then we just played around about infrastructure as a service. And today we are going to go a little above infrastructure as a service. I want to be talking about platform as a service. And platform as a service is still going to be under infrastructure, but we're going to be specifically talking about Docker, Dockerisation, Docker orchestration, Docker. So Docker seems to be one of the most interesting platform as a service that is selling, that is most most applicable application that is across the board. In fact, all CI/CD, DevOps, everything, you have to talk about Docker, Dockerfy, Makefy, Deep, etc. They are part of the system that you must set up, especially if you are operating in the microservices and you are not using a monolithic system, you are using a microservices. So if you are using a cloud native microservices, you must use Docker. Now, what is Docker? So I just did a little literature here. My name is again Satana Patrick Agbogu. I'm a senior DevOps engineer. Okay, now in our classes we talked about VM, but if you can understand VM, you can understand how to access private VM, then understanding Docker will be very easy for us, because a Docker is almost like a VM. It's just that it's an application. That's just the thing. So VM is a machine. For example, we have a bare metal, and that bare metal we put a system application called an hypervisor, and that hypervisor gives the VM the capacity and the functionality of virtualization, meaning of dividing that VM into different virtual parts, that everybody can use that VM differently and assume and act and think that they are working a different server. They're actually working in one server, but the server is being divided. The resources of the server is being divided, and everybody is working in different part of that server as if you're working in a standalone server. So that process is called virtualization, which is what gives the word VM, virtualized machine. You understand me? Virtual machine, that is VM. So that virtualization, last section, we talked about create an instance, create a VM. An instance is a portion of a server. It's a virtual portion of a server. You understand me? A virtual machine portion of a server is an instance. Just like you have oranges, you understand me? And that orange, if you open your orange, you remove the shares, you see that orange has so many partitions. You open the layer, you start taking one part of the orange part, you understand me? And that particular aspect of the orange you pick is an instance of that orange, because it has everything that a complete orange has. You understand me? So that process of dividing that orange as if you are eating a single orange, meanwhile that orange part you picked is actually a portion of the whole orange. Is called an instance of that orange. Just like in this case, we will not be seeing every other instance. We'll be seeing one instance. You understand what I'm trying to say? So you are taking a portion out of a VM, out of a server. So I'm going to give a pictorial explanation of it soon. Let me give you a picture of what a VM really looks like. Okay, hold on, give me a minute. Okay, so when you pick a VM, hold on, let me share a picture of what a VM really look like. Let's build our class the way we always build it, so that we can understand the real concept of VM and Dockerisation. Because if we don't do that, it can come very heavy on us and look as if the class is becoming more tough. Meanwhile, it's not tough. Okay, let's build it together. Before going to VM, let's take, for example, this. For example, this is a server. This is a server. This is a server. Before now, this whole server, a whole complete server like this, will be having just one application inside. And you have to connect it to a network in your local on-premise. That means your network must be local, and nobody can access that server anywhere except within that data center. Now, with the help of virtualization, which is also called an hypervisor, that hypervisor, when you place an hypervisor inside, with the help of this hypervisor, it's a system operating system. It's a system software, meaning it's a software that manages the system. So with this hypervisor now, we cannot divide this VM, this server into different portions. Let me make the portion bigger so that, because we are going to illustrate something. Okay, control. How many portions do we have now? 4 portions, Abi. These 4 portions will have different specifications, depends on how many. Because when you were creating your instance last time, you were dividing the system the way you want it. 1 core, 2 core, micro instance, EC2 micro, Abi. We are sharing the type of resources you want to create. But those resources we are creating, they were part of a complete server in a data center. And that server is called a bare metal. You understand me? A bare metal because it does not have an hypervisor. But when you now put an hypervisor on it, becomes this complete system is called a bare metal. But because of this hypervisor, this one becomes a VM. You understand me? So this complete unit is called a bare metal. Then this hypervisor now gives this system the opportunity to be shared. You understand me? So because like for example, when Prissy was commissioning a VM, it was commissioning this. Toby was commissioning this. Lakon was commissioning this. But when you were commissioning it and trying to log into it, you discover that you thought you were operating in one complete server. Abi? Please, I need response. Jay? Huh?
Yes.
It looks as if you are operating in a single server, because anything saved here is different from what is saved here. And you understand me? This one cannot see this. It's different from partitioning. But you were working with it separately, setting up a different network for it. You understand me? Subnet, everything. We were just doing it differently, but we were actually working from a server. So this particular portion of this server is called an instance. Are you getting me? This is a virtual machine, VM. You understand me? This is a VM. This is a VM, meaning it's a virtual machine. This is a VM. And this one here is also a VM. So all these VMs that we are inside, we install an Nginx in it, Abi. You're able to access it. If you notice that we immediately install Nginx in it, it means that different Nginx you'll be installing inside this server, and they will be acting as if they are different. But the challenge is that sometimes when you want to install another application, you need to carry an operating system. You must install an operating system. A big OS. Yeah. An OS. Remember when we installed Ubuntu Abi? We use Ubuntu, which is our OS Abi operating system, Ubuntu. Okay? Or we can decide to put CentOS or put any other VM in it, or any other operating system in it. So that with the help of this hypervisor enable this system, the server to be what? To be virtualized. So when we're putting our operating system, we're putting different operating systems. Imagine the operating system that you put in one is not the same operating system that will cut across all of them. You understand me? Our operating system will be based on the server that you are working with. For example, now let me put this one now. Maybe Toby now put Ubuntu here. They come inside not to put Ubuntu Abi. Maybe they come inside to put CentOS. CentOS, which is most times it's called EC2 AMI. Abi AMI, EC2 AMI, which is Amazon Machine Image. The same thing as CentOS. Let's say CentOS. Or any other Linux or Windows CentOS. Okay, now maybe Dolakpo will say, no, I don't want to put CentOS. I want to put this thing in my own. I want to put Windows. You can decide to put Windows here. And your third person may decide to put, maybe they don't want to put Windows, maybe want to put SUSE. Please take note of this. This is what infrastructure as a service is all about, SUSE. S-U-S-E. These are different variety of operating system. Now, immediately you put this one now, anytime you want to put an application, how many of us have installed Microsoft Word in our system, in our normal laptop? You notice that it comes so heavy, Abi. What's the size of Office? Maybe this is an application. Want to put an application? Maybe want to put Word. See, sometimes it's about 700. Sometimes it depends on the Word. If it's 2007 Office, it comes with about 700 megabytes. Abi, the installation file is about 700 megabytes. Abi, but there are some applications that you want to put inside this VM can come as high as, maybe let's use a simple application. Maybe you want to install CorelDRAW. Abi, CorelDRAW. That CorelDRAW sometimes is about 3.2 gigabytes GB. You understand? Maybe somebody want to put on the application. I'm just using a normal laptop to explain. Maybe what again? Toby again wants to put another application inside this software, inside this VM. You will take another application. For example, can you mention any application that you basically really use? Maybe VS Code, Abi. VS Code, Abi. If you look at your VS Code file, installation file, you see that it's as high as one gigabyte, 1 gig. Maybe you want to put, guys, how many gig now? 3.5 gig. I mean, this is 3.2 gig. Let's say VS Code is like 1.8 gig GB. Watch you. The reason why people are using Docker, that's what I'm trying to explain to you. I don't want to just go into definition and just get everybody. Let me use the word GIB, because if we are using server, it's called GIB, not GB. Let's use the word GIB. So let's really talk technically. GIB. Now, you want to install another application again. For example, you want to install, can you just mention any other application you want to install? Please tell me.
WhatsApp.
Huh?
WhatsApp.
Huh?
WhatsApp.
WhatsApp. Want to install WhatsApp?
Zoom.
WhatsApp. You want to install WhatsApp?
Zoom.
WhatsApp will carry like maybe 4 gig, or let's say 2 gig. Let me not make it too much, because sometimes WhatsApp application is not heavy. Maybe 200 megabytes. Then you want to install Zoom. Zoom takes space. You know, Zoom takes space. Okay, you want to install Zoom. I'm going to install Zoom. Zoom on VM takes almost like 2 gig. Imagine. So at the end of the day, if you look at, if this application has about maybe 20 gig hard drive, if we have like 20 gig hard drive, 20, okay, at default, when you are creating you only come with 10 MB and 10 GIB. At default, it will tell you to use 10 GIB. If you are using 10 gig in this VM, let's calculate the space that this application have collected. This is 3.2 AB plus 1.8, that's 5 gig. Yeah? This is 7 gig. This is 7.2 gig. You see, automatically the system is already telling you have 3 gig left. See? Yes. Now, if you now put another application, maybe you want to put another application, which application you want to put now? Maybe you want to put Photoshop. Photoshop is like a Kano election in Nigeria election. Photoshop. That Photoshop can carry like say 3 gig because it has some plugins. What happened to your memory, your space? It's filled up, Abby. So you only just have 1, 2, 3, 4, 5 applications. Your 10 gig is already filled up. Please, can you mute unless you want to say something? Please. Good. Okay, now, if you see, do you know why these applications are heavy? Do you know why? The reason why this application is heavy, let's take, for example, CorelDRAW. If CorelDRAW is coming to your system, for example, this is CorelDRAW. If CorelDRAW is coming to your system, it will come with so many things. One, it will come with, first of all, if CorelDRAW is coming to be installed in your system, first of all, it will come with the artifact of your operating system. That means, what do I mean by that? The kind of share it will need for it to run in your operating system, come with your artifacts or share. Then we'll come with another one, a payload. This payload is for the application to run well. They will now come with another, instrument. Say, it will come with, depending on the way you design the application, it comes with other dependencies, so many dependencies, so that those dependencies are the things that will make it to run in your operating system. So most of those dependencies, they are operating system dependent. Then before it will now come with the application itself. Imagine, this is the reason why it's going to take that space of how many gig? CorelDRAW will take the space of how many gig we talked about? 3.2 gig.
Sorry, Patrick, apart from artifact, you mentioned payload. I thought you were going to write payload there.
Yeah, sometimes you come, let's put payload here. Payload, so many things, but they are all called dependencies. They are dependent on the operating system. So that's what any application you are installing, all of them come with all these things. All of them come with all these things. So, so that they can work in isolation from every other application. There are some applications that cannot even run in your Windows operating system, but maybe they are Linux based. You understand me? It will also come with those dependencies to make sure that they function in your operating system. At the end of the day, those are all the application will come with it. All. That is why they are heavy. So imagine out of 10 gig application have collected how many space? 10 gig space. So you need to get more hard drive. That's why you see most of our laptop, we have many hard drives, but few applications are running inside. This one is okay when you are working on a personal laptop, but when it comes to working on a server that is very expensive, this kind of process is too expensive to maintain. You understand me? So this process is expensive to maintain. So that is why, that's what gave birth to Docker. So that's what gave birth to what? Docker. Let's put this one here. So what does Docker do? Okay, a Docker, we say, okay, fine. All this application that you mentioned now, all these dependencies you mentioned now, we can actually have one dependency that is for Linux only. And we can call it a Docker demo image. And put it here. Call this one Docker demo. So this Docker demo image is for its operating system dependence. I mean, we have for Ubuntu, we have for CentOS, just the way we have different operating system for this. You understand me? So, for example, now, if you are going to install, for example, this, we are installing it for CentOS, you put Docker for CentOS. You understand me? Yeah, okay, let me do it so that you don't confuse us in case we are revising it. So now we now put Docker demo. So with this help of this Docker demo image, any application you want to put, you don't need to put all this payload, all those dependencies again. You just put only the application, CorelDRAW. So this CorelDRAW could just be, maybe, for example, now let me put this CorelDRAW. This CorelDRAW file now, maybe is like 20 megabytes. So now it's not even up to 20 megabytes, 20 MB, MIB. You understand me? So imagine 20 MIB. So because you want to run this CorelDRAW in Windows application, you need to put all this artifact, payload, everything inside on top of the VM, on top of the operating system, so that you can run it. Abi? Now, what Docker does is that Docker just take all this thing, all this payload, artifact, everything, and zip it up in a container. You understand me? So the application itself will only come with 20 megabytes. This becomes the image. So which means this VSC code that is 1 gigabyte, because it carries all these artifacts, you don't need the artifact again. The VS code will now be like 20 megabytes, 20 MIB. Then the WhatsApp, that was 200 megabytes because you need to carry all those dependencies. Because those dependencies are already here in this Docker demo, what WhatsApp will now carry? Maybe 10, even 5 MB. 5 MIB. The Zoom that took 2 gig before, because Zoom, all these dependencies that Zoom needs to work is already in this Docker this thing, operating system that is supported for CentOS. So Docker for VM Zoom will not take how many bytes? Take like 10 MIB. So if you noticed it, Photoshop that was 203 gig, if Photoshop will just take like 100 MIB. CorelDRAW that was taking 3 point something, as I mentioned before, I think I've already talked. Okay, let's put CorelDRAW. CorelDRAW will just take like 3, let's say, because CorelDRAW is a graphical application, it will just take like 150 MIB. So now tell me, from this illustration I've explained now, if you are a businessman, which one will you go for? Operating system VM or Docker VM? Hello?
Docker VM.
Well, because if you take Docker VM, you now have
Everything.
you go on mute, yes, thank you. So with the help of a Docker VM, you can now load more application in this VM because the space is now small. Abi, this 10 gig that was occupied by just 5 applications. Now, if you look at everything here, it's not even up to 1 gig. Okay? So meaning you can have 50 applications, which is like 55 gig. You understand? And more application inside this VM because it has a Docker demo. So you now see that this is why Docker is highly in vogue, because there's a law in agile methodology, it's called lean. Lean is a part of agile methodology, LEAN, which is derived from a Japanese management company. It's a Japanese word, that explain that you only use the necessary resources. And reduce waste. This is why agile methodology is 100% accepted. So if you say you are a Scrum Master, you are all these things, and you're not talking about reducing cost, you are already, in fact, nobody will listen to you. Because cost management is part of agile system. The reason why a DevOps engineer is being employed is because of cost management. You understand me? Now, it will not only just make your VM light, do not make it fast. It can also carry more application. So I can decide to have 5 VSE code, 10 Zoom code, and spread the load balancer across it. Are you getting me? And manage it. That's where Kubernetes now came in. I will explain, I will use the opportunity to just plug into Kubernetes. You understand? So you now realize that with this Docker demo, which is operating system dependent, the disadvantage is that you cannot put a window Docker demo in a CentOS Docker demo. Every operating system that you have in your system must have its own Docker demo. You understand me? You understand? So we now have its own Docker demo. So you have for SUSE, we have for Ubuntu. As a matter of fact, Ubuntu comes with Docker already pre-installed. If you check Docker version in your Ubuntu system, now you see that it will tell you the version. Most VM that is cloud-based comes with Docker demo. You understand me? But you need to enable it and let it function. So any question? Let me use opportunity to just run a little into Kubernetes. Then we'll now come back to Docker and treat Docker very well. So that when we are talking about Kubernetes, you understand what Kubernetes is. Kubernetes is also another way of managing cost. You understand me? But just that what Kubernetes does is managing Docker. Let me not go far. Let me explain. Okay, now, maybe I told you that you have a VM, you have what we call a bare metal, which is a server. And that bare metal, you install an hypervisor so that you can be able to virtualize, and divide the VM so that it can work separately. Now, in that virtualization, you will now put operating system, which is what we did. Each virtual machine will have its own operating system. Then before, you have to put an application. When the application is coming, the application will come with its own artifacts, payloader, shares, nano shares, or operating system shares to enable the application to run in that operating system. Abi? That was what I said, Shane. Now, I now mentioned that with the help of a Docker demo, you don't need to carry all this necessary SS load that the application should have. The application should just come with just the application, which is called an image, and this Docker demo, which is the payloader and all the dependency that the application needs to function. So it becomes so light. You understand me? So because the application will not, every application will not be coming with all those artifacts, they will just be coming with just themselves. So the application will become so light, and the virtual machines will now have more application running in it. I think some of us have seen this design, Abby. I've seen this design, Che. Yeah? I've seen this
Yes.
Docker symbol.
Yes.
So this thing that looks like a fish is actually a Docker demo. Why all these things are actually the application, which I just explained to you earlier. So more application, you'll be putting more application as far as the VM can carry. So which means you will now have more application container. That's why they call it container. I say Boma will like this thing. If you are into importing, exporting, you understand that container is actually a zip of a particular load, and you understand me, that is owned by one person. So that is a Docker. Now let's go into Docker definition. What is a Docker? A Docker is a set of platform as a service products that use OS level virtualization to deliver software packages called containers. This service has both free premium and free tier. The software that holds the container is called a Docker engine, which is called Docker demo, which is this, and which is this Docker engine. Then Docker engine, and it was first started in 2013 and developed by Docker. So Docker is still very, very young. All of us here are older than Docker. I believe some of us have even graduated when this Docker thing started. I graduated about 6 years after this Docker was in from my university. I believe all of us have graduated since when Docker started. So Docker is relatively new, but Docker is almost like 9 years old. No. Yes, 9 years old. Next year, Docker will be 10 years. But it was not accepted like that until late 2017, 2018, 2019, 2020, and even different versions of Docker. So many servers, so many applications, so many things are coming up with their own Docker stuff. Docker is an open platform. It's an open platform for developing, shipping, and running applications. Docker enables you to separate your application from infrastructure, so you can deliver software quickly with Docker you can manage with Docker, you can manage your infrastructure in same ways you manage your application. So it's not like Docker has actually come to remove everything. Engineers in Docker is the same thing as engineers in VM. The environment, all those things that it carries is the same thing. You understand me? Why? Because it's the same application. It's just that it's not just carrying all those dependencies. So if you understand any application before, the same thing. Just that this time you're not going to be carrying all those SSs to put it when you are deploying it. You are just carrying the application. You're deploying it. Now there's a place where they save all this Docker image that was already been developed by people. It's called a Docker hub. The meaning of hub means things that connect people together. So I can design to make an application, maybe a Microsoft Office in a Docker file. I'll create an account, just the way you create GitHub account. You also go there and create a Docker account, and put my application inside that place. So that when you want to use Microsoft Office, the first thing you need to first of all do, after you have set up your VM, you just put your Docker on it. Then you carry Microsoft Office. From that Docker hub, you just zip it inside your container and you start it. You just start working. So is there anything difficult here? Is there anything complicated in this place?
Not at all.
So the Docker people are talking about Docker. Does it look that complicated? Does it look difficult?
The explanation makes it look more easier than the name sounds.
So as I mentioned, most times what brings the fear in learning is the rumor behind those that don't know it, or those that have not even tried it. But I remember when I was in school, there was one course called thermodynamics. I was in a lower class when I started hearing about that course, thermodynamics. As a matter of fact, immediately I joined that class that was doing that thermodynamics, the fear was already in my mind, because those people that didn't know it have already put the fear in us that thermodynamics, thermobiologic is difficult. But when I get to understand the course, that it's not really difficult, it's talking about the heat transfer and anything about heat, which is relative, because at least I can relate to heat, I can relate to temperature. It becomes so easy, but the fear was already there. Dockerisation, Docker orchestration is simple as VM. What is the same thing, just that the way you open port for VM, Abi, the same way you also open port in Docker. The way you network VM, the same way you network Docker. There's nothing there. Why are people using Docker? It's because of economic. I believe the people that started this Docker, either they are more of economic people, they want to, it's not more of economic people, it's about reducing waste and making it easy. Can you imagine? You know how long it takes? It will take you to download an application of 3.2 gig because you want to install it. Imagine if you have a data, you just subscribe for 2 gig, for 10 gig data, and they ask you which of them will you want to go for. Is it an application that will take 3 gig, or an application that will take 20 megabytes? You just take 20 megabytes. As far as it's working. Abi, let me tell you the truth. This Docker, because it's light, does not make this application that is 3 gig better. As a matter of fact, this 3 gig is slower, it's not portable, it's dragging. Because those payloads, sometimes it can have issues, it can crash. You understand me? Some things can go wrong. This one, the only thing that can go wrong is your Docker. If your Docker goes wrong, you remove it, you install another one, and you run it again. It works. You understand? So, and the Docker is light. It's not like an operating system you keep operating. Like, for example, now, if you want to put a Linux in this system, you have to put another, what they call virtual machine and other things. You don't need to be zipping. Just which application I want to run. I want to run a CentOS. Okay, CentOS demo. Put back, you run all the application you want to do, start putting all the application. Now let me just quickly talk about Kubernetes. Kubernetes is the same thing as, it's called Docker orchestration. Kubernetes is not the only Docker orchestrator. We have so many Docker orchestrators. What do you mean by Docker orchestration? Remember I told you a Docker is actually an application that is being put inside a container to run on a machine that has a Docker machine under it, a Docker demo. That is, all these things are container now, because they are running on that Docker. Now, these containers, they run separately. Like if you want to install Microsoft, for example, you are installing two applications now. Maybe I install CorelDRAW, and I want anybody that want to access this CorelDRAW must put their username and password, must have a database. So I'll install a database called RODS. Let me put this RODS here. Maybe my SQL, my SQL will just take, anybody that enter this site and put their data, this my SQL will keep it, This my SQL has a port, What's the port of my SQL? I think it's 3306 or something like that. Why this application, let's assume this application has a port, it's default port of 5000. So what I will do, I will open this port, just like the way we open our security group, to accept this traffic. And I will open this port to send traffic to this place. Then I will put this username and this password. I will link these two applications together. When I link these two applications together, automatically this application can now communicate with one another, because I've used a port to communicate with them. This is how Docker works. Docker works by networking. If you want two Docker applications to work, to function in the same container, in the same VM, you have to network it using, you understand me? You have to make sure that this port is open, this port is open, you understand me, on these two ports. Then you tell this port to communicate to this port. You use a file, a Docker file, to explain this port communication. Now, for example, if I'm running 20, for example, now, if this Docker file goes off, maybe as I'm running this Docker file, there was an issue, maybe 5,000 loads come on it. Maybe this Docker application can only accommodate 3,000. Please stay with me on this. Can only accommodate 3,000 users. And maybe because somebody now attack it using what we call DDoS attack, maybe now send some kind of traffic into this Docker. The Docker container will die, This application will no longer be available, When this application is no longer available, what will happen? This place will be open and my application will be offline and there will be no availability, This is the challenge Docker always have. Just the way a VM also have. VM, when a VM dies, when a VM dies, it will not accept traffic. We explained it in our load balancer last class. We use a load balancer. When a VM dies, it goes off. But use a load balancer to organize 3 VM together. Maybe one in private, this is public, this one is private, this one is private, this one is private. You now use a load balancer, like what we did in our last class. Let me also illustrate it so that we know that we are seeing the same class. This is a load balancer. We'll now put a load balancer to send traffic to here, This was our illustration last class, Control D. Can you understand? This was what we did last time, Am I speaking jargons? Are you guys still with me?
Yeah, well, with you.
Okay. Now, we now put the load balancer here, Control D, here. Here. This is what we did last class. This is a VM. For example, this is our public VM. These are private VMs. They will put different applications inside because we don't want, if this application are the same application, we don't want this application to go off. We put a load balancer and we say that in case there's somebody is trying to access this application, we access it through this load balancer. So any VM that is available will be the one to accept traffic. This is a complete VM. Imagine a whole VM be carrying 1 or 2 applications. But with the help of this Docker now, instead of putting just one application in this VM, you can put 20 applications inside this VM. And this VM will be the Docker we're talking about. You understand me? So this VM is the same thing as this Docker. So there's no difference between a Docker and a VM, but just that a VM is a complete virtual machine, while a Docker is a container that runs like a VM, meaning it can carry an application and hide an application, and can also accept traffic from the public, from the outside. Now, let me talk about Kubernetes. What the Kubernetes does is this. The Kubernetes will now be able to manage this Docker so that in case anyone goes off, it will create another one. You understand me? Maybe this one dies. You understand me? The Kubernetes will replace it immediately. Self-healing. You understand me? Maybe there's a load. The load is coming onto this place. Because this container is inside this VM, what the Kubernetes will do if you design it very well, if the load is 3,000 and the load is going to 4,000, 5,000, let's say 5,000, if you design it very well using an HPA, that's horizontal auto scaling pod, what we do is that Kubernetes will quickly create another VM so that it can carry more traffic, another Docker file. So the process of managing this Docker, deleting Docker, increasing Docker, connecting Docker together, that process is called orchestration. So when you say Docker orchestration, it's actually talking about management of Docker. So the process of managing all this Docker is called orchestration. You know orchestra. Many of us have heard of orchestra. Orchestra is like a group of musicians, that all of them play different type of instruments. Yeah? Huh? Oh.
Yeah, we were with you.
All of them play different instruments, but the lead of the orchestra can direct where to stop. You know, they hold one stick and be doing pom, you know, just like a puppet, telling them stop, increase, decrease, you leave the queue, you moving out of the queue. That process of managing those small music group inside is called orchestration. So that's the word that they actually adopted into this place. So the process of managing all these Docker, increasing the Docker, reducing the Docker, managing the Docker, healing the Docker is called orchestration, because the person that is orchestrating this thing is called a Kubernetes engine. Or you can also, it's not like Kubernetes is the only Docker orchestration. There are many Docker orchestrations, just like Kubernetes is having more wave. You can call it K8s. You understand me? You can call it K8s. Or Kubernetes, the same thing. So it's just like it's an orchestra. It's like the lead telling how many container will be increased, how many container will go off, how many container will do. So it's also an application. But the work of that application is just that it's not only managing just a Docker application inside a particular VM, but it has the capacity to manage all the, if you connect all this application together, all this VM together, you understand me? All this virtual machine together, it has the capacity to increase, to manage both this VM and put all this application that's in one and spread it in all. You understand me? So the work of a Kubernetes engine is just like a manager that manages all the Docker application inside. Just that this time, it's not only managing just one VM, it's managing a multiple VM. If it's managing one VM, you call it a mini cube. You've heard of the word mini cube, Abby? A mini cube is a Kubernetes within one particular instance. But if it's more than a computer, a particular instance is more than just it's called Kubernetes engine, because each of these VM becomes a node. And the particular Docker a container inside. It's no longer called a container, it becomes a pod. I'll explain to you when we get to this place, but I just want you to have an idea, the difference between a Docker, a VM, and a Kubernetes engine. So that's all the difference. A VM, so it actually starts with a bare metal. Okay. A bare metal is a server. You understand it? A server is a bare metal. Now, when you put an hypervisor on top of that server, the server, you can now divide the server into different portions, which makes that server a VM. You understand? Now, because you want to put the application inside this VM, those applications will come with so many artifacts, so many things that will make this application to work in that particular operating system. So it makes the application heavy. So to reduce this always carrying too many applications inside because you want to run in an operating system, that's why you now put a Docker machine or a Docker demo on top of a VM. You understand me? So because of that, because all this dependency is already inside this place, so the application will only just come with the little thing it needs for it to function. And you will not put so many applications in that VM. Now to manage those Docker applications inside those VM, you need a machine that can help you. An example of that machine is Kubernetes. Another example is called a Docker Swarm. We have another one called Docker Swarm. And I know between now and next 5 years or next 3 years, many is going to come. We have another one called Docker Swarm. A Docker Swarm is the same thing. It works like a Docker, like a Kubernetes. You also help, just that most times Docker Swarm manages all the Docker in one particular VM. You can also manage Docker in other VMs. But Kubernetes enjoy this strong capacity that when you are installing the Kubernetes, it will have one plane, which is called a master plane. And that's where all the engine, the control comes in. Then you will now have other nodes, which is normal VM that you attach to it. Please, I will get to that part. We're going to practicalize this thing starting from tomorrow. So it's going to be fun. There's nothing here. It's just the same thing. That's why I said the most important thing I need to lecture you guys is how to set up this VM, because this VM is still the main thing. You see all these things I'm talking about, are they not on top of VM? Che? Are they not on top of VM?
True, very true.
Are they not, at this VM, is it not sitting on the network?
Yes, it is.
So if you want to install WordPress, a Docker WordPress, anything, are you not going to first of all install a VM? That is infrastructure as a service. If you can understand infrastructure as a service, every other thing, including Docker, Kubernetes, CI/CD, everything becomes so easy for you. It becomes so easy. There's nothing. In fact, you can go ahead and start practicing. Some of us, you don't even have opportunity of having a class for Docker, but we had the opportunity of learning infrastructure as a service. We went about ourselves and start practicing, because it is of recent that we now have so many materials. Then there was no material. You understand me? Just like this is what is raining now. This is what people are using to cut costs now. Please, if you must follow IT trends, follow trends that cut costs. You will always be relevant. Why is DevOps more interesting? Why are people going looking for DevOps engineer? It's to cut costs. So if you are a DevOps engineer, you can perform infrastructure service, you can perform operation, you can even support the developer. Some developers can even develop. So instead of employing 4 people, you just employ 1 person, and the 1 person will do the 4 job. Is it not cutting costs? Eh? Hello, answer me.
Yes.
Yes, of course.
Reducing
Yeah.
cost, yes.
For example, me now, my way I work, we do monitoring. We perform some SRE activities. We set up a complete production environment. That's infrastructure. We use infrastructure as a code. which is another class we're going to talk after we finish the Docker and Kubernetes. We're going to infrastructure as a code. I think after infrastructure as a code, normally I'm supposed to take infrastructure as a code before going to Docker. I realized that sometimes by the time you go infrastructure as a code, people will just get so tired. By the time you're now coming back to Docker, to now look as if you're starting all over again. No, let's get Docker sorted, let's get Kubernetes sorted. Then we'll go to infrastructure as a code. How to now use code to do all these things. Then we'll start doing our application deployment and everything, do our CI/CD. Then we are done. And I can vouch for you. This training you just had is in millions. No company wants to pay to train you in all these things. So they expect you to go and learn it and master it so that by the time they employ you, you start working for them. So nobody wants to pay for any training. That is the reason they are looking for experienced people. So if you can train yourself, the company will pay you for the training you have given to yourself, and they will make sure that you are relaxed, because they know that if you are good, you'll be running up and down and people will be giving you big money to live. Just like a footballer that is a very good scholar, like for example, Cristiano Ronaldo. To see Ronaldo leave Manchester United today, somebody else will buy him. The same thing with all the superstars. So right now, the DevOps engineer is a superstar. If you are good, you understand? People will come to your DM and start begging you for a job. It's true. Because why? They know that you as a DevOps engineer, you are able to set up infrastructure, set up Docker and Docker orchestration and Kubernetes and everything. And one man, one person doing everything. So instead of if you notice that nowadays they don't even advertise for network engineering. Have you noticed recently they don't really advertise on network engineering again? You noticed it? No. It's not that they don't need network engineers, but in a many minima. They don't advertise for NOC again. They don't advertise for IT support like that. They just want a DevOps engineer because they want one person that can do many roles. They just want, everybody's going to cut costs. Everybody wants things to be easy because the DevOps engineer, when you automate the system, you provide infrastructure, you provide security, you monitor infrastructure, you do troubleshooting. You understand me? Tip cost troubleshooting. You are the last man standing. You help them to reduce cost. Who will not employ you? Why would they pay you big money to keep you? You understand? Because you're actually saving cost for them. So that is just it. I believe I've done some justice to this Docker thing today. Tomorrow we are going to be talking about how to use Docker container, how to put a Docker in an application, how to run a Docker application, how to put this demo, how to look for any application and start zipping it on top as an image. It's called image. We'll create a Docker account tomorrow if you don't have a Docker account, so that the one you can run locally, you run locally. The one you cannot run locally, you can go and zip it. In AWS, there is a Docker registry or a Docker artifact, just like a Docker hub is. You understand me? So instead of you to be putting all your Docker file that you have built in a company, you understand, they prefer you put it in a private repository, which is called Elastic Container Registry, ECS, ECRO. You understand me? So any application that you already built and Dockerized, you just put it inside that stuff. I will explain to you the difference between a Docker image, a Docker container, and a Docker artifact tomorrow. They look alike, but they are not really alike. You understand me? So that is just it. So any question? Do you enjoy today's class?
Yeah, I did.
Is there anything difficult that I have not mentioned? Is there anything difficult?
Is Kubernetes something like a load balancer?
It's more than a load balancer. Kubernetes.
If one goes off, Kubernetes will spin off a new one. So that's what load balancer do.
No, a load balancer, what a load balancer does is that it look out for the VM, like this load balancer. If this VM is out, has a fault, it removes it. Are you getting me? It removes it and allow the remaining one that is running to work. But Kubernetes does not. Kubernetes will create another Docker. It will create another container. and put all those applications that was running the former one inside, and they will keep running as if nothing happened. That is self-healing. But load balancer does not do that. A Kubernetes manage is like it has a file called deployment file. Anything you put in that deployment file, as far as you deploy that file in that Kubernetes engine, that services must keep running unless your deployment file is wrong or your image you are using to run is wrong. As far as that image is running, and that load is up, that container will be up. If there's an issue you will not know, we destroy it, we create another one. You will keep managing it for you because there's a file called a deployment file. I'm going to explain that. So it's more than, it also performs load balancer because in Kubernetes, you also can define a load balancer, deployment file, service, nginx controller, networking, ingress, all those things. It's going to be fun. We're going to be having fun. I gave you an assignment on Kubernetes one time to look at it. If you actually did that class, this class will become easy for you. But still, don't worry, it's still going to be easy. I'll do my best to make it easy for all of us. But just understand the difference between a container. So because the question that will ask you most times in interview, what is the difference between a VM and a Docker? So it's a trickish question. So if you can explain this, which I just did, you've gotten they will know that you know what you are talking about. And that is a plus for you. So any other question? Okay, now let me answer that question here now. Assuming this is an interview, what is the difference? I want all of us here, we say something. Please, let's try and say something. Yeah, is that okay? Don't worry. If you don't want to say anything, don't worry. But I will recommend you say something because you are going for interview, because I'm not preparing you to go and do this thing and go home and start sleeping. I'm preparing all of us so that you can take up a role as a DevOps engineer or even as a cloud engineer and function well. And for you to take that role, somebody have to ask you some questions to really know if you understand what you think or what you say you are. So that's the reason I'm asking this question. So anybody can start answering. I'm not going to call names for today. What is the difference between a Docker and a VM? Please, anybody can start answer that question. Please. Give it a shot.
Big six.
Go ahead, give it a shot. Don't worry. Okay, let me stop recording. Excuse me. Am I even recording at all? Yes, I am. The basic differences between a VM and a Docker is this. A VM is a part of infrastructure as a service, meaning you need it for infrastructure, for a cloud infrastructure to be successful. Without a VM, infrastructure as a service is not complete. You understand me? It's part of infrastructure as a service. A VM needs an hypervisor to be on top of a bare metal. I'm told you what's a bare metal. A bare metal is a simple server, a complete physical server is called a bare metal. A VM allows an operating system, and a VM accepts an application. An application that is on top of that VM could also be a Docker. You understand me? Because Docker is also part of system software. You understand me? So a VM can carry Docker, but a Docker cannot carry a VM. You understand me? Because a Docker can be part of a VM because you can install a Docker because it's an application on top of a VM. Meanwhile, a VM also have its own networking. So if it's part of the network as a service, so this already covers that network. Meanwhile, a Docker is part of platform as a service. a Docker requires a Docker demo or a Docker machine. And a Docker is dependent on an OS. Meaning, if you want to put a Docker application is dependent on an OS. Let me put it that way, that can be simple. Docker app is dependent on an OS. Meaning, if you want to put an application for Windows, you cannot put a Docker for CentOS for Docker for Windows. So you have to put a Docker version for Windows. You understand me? And all the applications that must run in this Windows must be a Docker related for Windows. So if the operating system is Windows, the Docker that you are putting there must be what? Windows. Everything, all the application must be what? Windows type. But for application running in VM, it can be either Docker. You can even have, there are some applications that comes with what we call it, a bridge, a form of a bridge, an adapter that enables other application to run inside. I think there's a name for it. I remember the name. So it can even run a Linux VM application in a Windows application inside a VM. That's why it's called a VM. But when it comes to Docker, because the dependency inside this Docker demo is the dependency of this application that's supposed to come with it individually, that is being zipped here. So if you now put a Windows application here, because the Windows application is not part of this demo, it will not run. You understand me? So it must be on top of this VM. So it must, the application in Docker are OS dependent. Now it allows portable application to run because that means it can accommodate more application. Let me put this one here. Can accommodate more app, and it gives birth, it gives room for orchestration. So it's because of the function, because Docker is alive. That is why Kubernetes is possible. You understand me? That's why Kubernetes is possible. So now, one VM now can carry 20 applications because there's Docker to orchestrate it, to manage it. So you'll be rest assured that you can give yourself and say, as far as that VM is running, that application will not go down. As far as it's running in the cloud, that application cannot go down. You understand me? Because cloud has a VM and a Docker is giving that VM more application to carry. And Docker orchestrator, like the Kubernetes and the Docker Swarm, is managing those VMs so that in case anyone dies, another one can come up. You understand me? And connecting the orchestration and doing everything together. And this is why this part of our class is very important. Please don't miss tomorrow's class. It's going to be continuation of where we stop. And we're going to be practicing it. And you're going to see how simple Docker is. And Dockerfile, Makefile, etc., etc., etc. This is the handshake between a developer and operation. And that's where you come in, because the handshake between developer and operation is called DevOps. For me now, every company I work for as a DevOps engineer, my work actually starts from the Dockerfile. You guys have the build the application is running. Okay, can I see the Dockerfile? I will use the Dockerfile to design it to be able to align with the CI/CD pipeline we are using. So that because the CI/CD pipeline also uses the Docker. You understand me? So we're going to start having fun now. This is from here onward is fun. So that's all. Thank you so much for today. So any question? So you can see the difference, Abi. The difference is very easy. Shay?
Yes, sir.
So you see, I just listed the main difference, but there are more. You can also go and do your research. Okay.
So Patrick,
Why is the class quiet?
when you're done, if you help me check my laptop for the charges.
Okay, I'll do that. Any other question, please? Why is this class quiet now? What did they happen?
Oh, none from my end.
We did enjoy them. Only say I understand beginning.
And it was very, I mean, it was loaded, full of,
Loaded.
yeah, full of new learnings.
As a matter of fact, this is the first time I'm actually treating Docker. Because sometimes I always think it's very easy for people to just go and do by themselves. Until I noticed that since this is not really my first time, but this is like the first time I'm actually going in depth. So I felt it's easy, but I noticed that even some of our developers are even having issues with this thing. So this class will come handy. Please, can we mute your mic, please? So this class can come very handy to anybody. So if you know any developers, anybody that is interested in infrastructure, especially Docker aspects, tell them to come and take this class and master it. And tomorrow and practice. And everything will be so fine. So thank you so much for today. And I appreciate your coming. And please, we'll see you tomorrow. This video will be uploaded ASAP when immediately finish building. Okay, thank you. So I'll see you tomorrow, same time, same station. Thank you for tuning in to Cloud Training for Enthusiasts. Yeah, your dream to Cloud Fairyland comes true. My name is Osatawe Patrick Aigbogun. I'll see you tomorrow. Bye. Bye-bye.
Bye.
Thanks for having us.